So as mentioned in the problem statement, we have to print output like this, that odd thread should come first and it should print I is equal to 1, whatever the counter is. And then the even thread should take over and so on. But the here catch is the more important point is that the odd thread should come before the even thread. So here in this case, once we are running this our test, so whether we start, so the CPU will schedule any thread from, it can schedule even thread first before odd thread, or odd thread can first. But here in both the cases, whether it's even thread is started first or odd thread is started first, we have to only like execute I is equal to 1 first for the odd thread. So and in that scenario, even thread should wait for the first time. So this is the most important thing that we have to cover here in this our run case. So let's run this. Let's write coding this. Let's start with int I. Declare a variable as I. Start with 1, and we have to check that if it's an even number. If not is odd, means that if it's an even number, then I should start with 2, right? So for odd thread, I should be starting from 1, and for even, it should be starting with 2, by just checking this basic condition. And now we have to loop for this I. So I will just use this for I, and okay, so I will remove this. I don't want this, and I will use I again till I is less than equal to 100. I plus equal to 2, because we have to jump for each of them by 2. In each of this iteration, we will be printing odd and even numbers together, and that's why we have to increment by 2. And now we are using this monitor, right? So monitor, we have to consider that whether we have to wait and toggle the turn for odd thread and even thread. So for that, what I will do is that I will first of all, let me print out the statement. So I will have this statement, because we need to print exactly like this, that I is equal to this, and then followed with the thread name. So here I can write this I is equal to %10 %d as a placeholder, and inside this %s will be the thread name, and then a new line. And here we will be printing I and thread dot current thread dot get name, right? This is what we will get by what we have printed here, odd thread and even thread. The name would be printed here by using this get name method. Okay. So this would be exactly same as what is given here. It should be I is equal to 1 comma, and in brackets we have covered the thread name. We are doing the same thing, I is equal to I, and then in the placeholder we are putting the thread name. But before we print it, right, we have to like do the actual synchronization or actual coordination between these odd and thread and even thread using the monitor object. So I need to have one way that we have to wait turn for one thread, and then when that thread is printed this statement, then we have to toggle the turn. So for example, if odd thread is running right now and then it has printed this statement, after that it will toggle the turn so that even thread can take over. So for here I will start with that. First of all, I need to wait. I just call a wait turn method, wait turn, and I will pass whether it's an odd or an even. I haven't created this method yet, but I will create it soon. But the idea is that this should be actually synchronized here and toggle turn. So wait turn is that, based on whether it's an odd or even thread, it will wait accordingly. And starting with odd thread, right? Suppose odd thread enters here, and then it will wait a turn. If it hasn't printed, it has already printed like an odd number before, then it will wait. But for even thread, when it comes and it says that the odd thread has not done yet, then only the odd thread will continue and print the statement, and then it will toggle the turn so that the even thread can print it now. So it will be more evident once we actually implement this code. So let's implement this code first. So I will alt enter and create method wait turn. Similarly, I will create this method as well so that it doesn't show me the red signal. So toggle turn. Okay. Now let's implement this odd even monitor here. That how we are going to coordinate using this wait turn and toggle turn. So first of all, I will create a re-entrant lock, and we will using the condition object here. So let's write this first. So I will create a re-entrant lock, re-entrant lock, and call it just as a lock and new re-entrant lock. Okay, do all L, and in this lock we will have a condition which would be toggle turn condition, and this condition would be used for coordination between the odd thread and even thread. For this also we can create this condition, and I will call this as toggle turn condition. We could also use wait and notify method here, but I will prefer to use this one. Okay, so we got this wait, and then let's start with very first that we have this a boolean flag turn is equal to true, and this is the boolean flag. This is our critical section which would be monitored by this condition. So let's write, and it will be more evident that what we are trying to do. So I will initialize this with true, and then we will toggle it accordingly in this toggle turn. So toggle turn would be very straightforward. Let me implement that first. It would be very simple. Toggle turn means that if the turn is here is true, it will convert it into false.